Welcome back, everyone. Today, we are looking at something completely different and, frankly, revolutionary for your revision. We are opening up the examiner's playbook to master one of the most notoriously misunderstood concepts across the Cambridge syllabuses: center of gravity and stability. If you are sitting for syllabus codes 0625, 0651, 0652, 5054, or 9702, listen up, because this explainer is your definitive legal brief. Think about it for a second. When a top absolute powerhouse barrister walks into a courtroom, they don't just stand there and throw random disjointed facts at a judge, hoping something sticks. No way. They build a case. They have rock-solid evidence, a structured, impenetrable argument, and a completely undeniable conclusion. And honestly, that is exactly how you need to approach your Cambridge physics exams. It's not just about knowing the math, it's about making your case. We are going to look directly at the ultimate source material today, the Cambridge Principal Examiner reports, to show you exactly how to build your case and secure every single mark available. We're going to transform your extended responses from messy guesswork into razor-sharp, examiner-pleasing legal briefs.
So, right off the bat, you've got to ask, why is center of gravity so notoriously misunderstood in these exams? To answer this, let's look at a real Cambridge physics past paper question from syllabus code 0625. The question asks candidates to explain the effect of a low center of gravity on a racing car. Okay, simple enough, right? Well, let's look at two totally different ways this goes wrong. On the left side of your screen, we have Alex. Now, Alex is the classic over-preparer. Alex overloads the page with raw physics facts about mass, gravitational field strength, and Newton's laws. It's like a textbook exploded on the page. But here's the catch. Alex provides absolutely zero analysis of the actual racing car. As a result, the examiner's red pen is literally everywhere because Alex didn't answer this specific question. Now look on the right. Here we have Sam. Sam rushes through the paper, writes down "it doesn't fall over" because it's low, and completely misses the command word requirements. Sam just didn't provide the depth needed. Again, red marks everywhere. Multi-stage analysis is really tough, guys. It requires discipline. But over the next few minutes, we are going to systematically hack this exam structure together and turn every single one of those red marks into beautiful green check marks.
Here is our quick roadmap for today. We'll be hitting core physics principles, moving on to the classic lamina experiment, diving into the stability of simple objects, revealing the method mark strategy, and wrapping up with the top examiner warnings. Let's jump right in.
Starting off with Section 1, Core Physics Principles. Okay, theoretical foundations are what examiners look for before absolutely anything else. You cannot build a compelling argument in your exam if you don't understand the exact definitions and the command words the examiner is using. Notice how incredibly, almost painfully precise this definition is on screen. The center of gravity is the specific point where the entire weight of an object appears to act. I want you to really read that again. It's not where the mass is. It is not the middle of the object. It is the specific point where the entire weight appears to act. The principal examiner reports explicitly highlight these definitions as the ultimate foundation for top marks. If you start your extended response by dropping this exact word-for-word definition, you immediately lay down an undeniable starting point. You're basically telling the examiner, hey, I know the exact physical principles at play here. Remember, weight is a force, right? It's a vector acting straight down towards the center of the Earth. If you don't specify that it appears to act from this specific point, your evidence just completely falls apart in the courtroom of the exam hall.
This perfectly illustrates why rote memorization just isn't enough anymore. Cambridge actively assesses three distinct cognitive domains: knowledge and understanding, application, and analysis. Remember Alex, our student from earlier? Alex had all the knowledge in the world, but absolutely zero application. And Sam? Sam tried to apply a really basic thought, but totally lacked the structural analysis to back it up. Examiners are testing these domains simultaneously. You have to recall the fact, apply it to the specific diagram on the paper, whether that's a crane, a double-decker bus, or a racing car, and then analyze why the physics behaves that way. This is where the Peel framework becomes your best friend: point, evidence, explanation, link. If you just say, the object is stable because its center of gravity is low, you aren't doing enough. That's a weak argument. But if you use Peel and say, the object is stable because the line of action of its weight falls within its wide base, creating a restoring moment rather than a toppling moment, boom, you have hit all three assessment domains perfectly. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, moving right along to Section 2, the lamina experiment.
This right here is where we see the ultimate transformation from a struggling student to an absolute exam-acing master. Determining the center of gravity for an irregularly shaped plane lamina is a classic, super high-value exam staple across the 0625, 0652, and 5054 syllabuses. It comes up all the time. Why? Because the examiners love it. It tests your procedural knowledge, your practical skills, and your spatial reasoning all at once. The absolute crucial point here is knowing the exact physical steps perfectly ordered. Step 1. Suspend the lamina freely from a pin. Step 2. Hang a plumb line from the pin. Step 3. Trace the vertical line. Step 4. Repeat from a totally new point to find the intersection. Now, why does this exact sequence magically add marks? Because every single step represents a method mark. When Sam wrote, "hang it and draw lines," Sam got maybe 1 mark. But by explicitly mentioning the plumb line and suspending it freely, Sam secures full, undeniable marks. The physics behind this is actually really elegant. When the lamina hangs freely, its center of gravity must lie vertically below the suspension point for it to be in equilibrium. So the intersection of 2 of those vertical lines gives you the exact coordinate. It's brilliant, and you need to know it cold. Let's step into Section 3, Stability of Simple Objects. Now that we have our theoretical definitions and our experimental methodology locked down, let's actually apply them to the real-world objects that Cambridge examiners absolutely love to test you on. We're talking things like Bunsen burners, racing cars, and drinking glasses. Stability is all about how an object responds when it is momentarily displaced. Does it bounce back to its original position, or does the whole thing just topple over? Let's do a quick interactive workshop right now. I want you to run a 60-second timer in your head. Do a quick data scan of this table on the screen, comparing center of gravity position, base width, and resulting stability. What is the ultimate formula for maximum stability? Look closely. An object with a high center of gravity and a narrow base results in low stability. Think of a really tall, ridiculously thin wine glass. 1 tap and it's gone. But an object with a low center of gravity and a wide base results in high stability. Think of a Formula 1 racing car hugging the track. This table right here is your ultimate quick mental heuristic for exam problem solving. When you see a question asking how to modify a design to make it safer or more stable, your brain should immediately flash to this exact table. Widen the base. Lower the mass. It's that simple. Stop scrolling. Subscribe to our YouTube channel ACD Exams at ACDExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @ACDExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Now we're getting into the real insider secrets. Section 4. The Method Mark Strategy.
I call this the method mark spotlight. It's the concept that the actual process you use to solve a problem is heavily rewarded by Cambridge examiners, even if your final calculation is completely off because you made a silly calculator error. But here's the reality check. If the examiner cannot follow your logic, they cannot award you those method marks. It's impossible. Let's play find the flaw for a second. A massive flaw many students make is a lack of precise physics terminology. Imagine reading a paragraph that says, "the car is too heavy at the top," instead of "the car has a high center of gravity," or saying "it falls down" instead of "the resultant turning moment causes toppling." That sloppy language is exactly where marks disappear. To ensure you lock in those method marks and fix that flawed logic, you need to use this 3-step cognitive framework: deconstruct, solve, and evaluate. First, deconstruct the question. Identify your given information, figure out exactly what the command word is demanding, and break it into logical steps. Second, solve. Apply your physics principles systematically. We're talking clear notation, clear working. Third, evaluate. Do a reality check for reasonableness. Does your answer actually make physical sense? Look, if you calculate the center of gravity of a 10-meter flagpole to be 50 meters away, you know for a fact you've made a mistake. Take 30 seconds to mentally speedwrite a peel paragraph in your head verifying your answer. Evaluating your own evidence quality and clearly articulating your assumptions, that is the exact difference between an A and an A star.
And finally, Section 5. Top Examiner Warnings.
We are going to complete our entire physics answering system right now by revealing some highly valuable insights harvested straight from the Cambridge Principal Examiner reports. These are the specific, painful areas where thousands of students bleed marks every single year. The absolutely #1 warning from examiners is that candidates consistently, year after year, confuse cause and effect in questions about center of gravity and stability. Look at the timeline on the screen. A student might write, "the object topples, therefore its center of gravity is outside the base." No, stop right there. That is completely backwards. The object's line of action of its weight falling outside its base is the cause. It is the underlying physical reality. The resulting turning moment, or torque, which actually makes the object topple over, is the effect. If you write the effect as the cause, examiners are strictly instructed to withhold your marks because it shows a really fundamental misunderstanding of the physics timeline. By visually contrasting these two things right now, you clear up the single most common conceptual trap. Rule of thumb: always start with the physics cause, and then describe the physical effect.
Let's cleanly list out the top 3 mistakes so you know exactly what pitfalls to dodge on exam day. Number 1, confusing cause and effect, which we just hammered home. Don't do it. Number 2, forgetting to check format and presentation. Examiners specifically note that students often use incorrect terminology. They totally forget their units, or they fail to define key terms before using them in their extended responses. Guys, presentation matters immensely. Clear headings, correct formats, and highly clear annotations on your diagrams are absolutely vital. Don't make the examiner guess what you mean. Number 3, giving answers that are not specific to the context. This goes back to Alex from the beginning. If the question is about a double-decker bus, do not just give a generic textbook definition of stability and walk away. You must apply the core principles directly to the bus, discuss its wide wheelbase, discuss its heavily weighted chassis, make it relevant.
Which brings us to a really powerful conclusion, taken directly from the Principal Examiner report. The assessment framework prioritizes analytical depth over superficial breadth. Let that sink in. They do not want you to memorize an entire textbook and just vomit it onto the page like Alex did. That doesn't impress anyone. They want you to take one specific concept, like the precise location of the center of gravity, and analyze it deeply, step by step, just like a barrister making an airtight, unwinnable case in a courtroom. So my final provocative question for you is this: how are you going to change your study strategy today based on these examiner insights? Are you going to continue to just passively read the textbook, or are you going to start building your legal brief? Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.